Welcome to Laser Projector Technology. Today we will describe solid-state light source technology, the advantages and disadvantages, and what it does for you and your customers alike. In this section we will describe the advantages of SSL. So advantages of laser phosphor, you saw this before, 20,000 hours of operation. That's at maximum brightness. Most important, of course, no lamp replacement, so the maintenance free becomes very important. When we're looking at education markets, if we don't have to go in and replace lamps and projectors that are in a lecture hall, that's a huge benefit to the university. Redundancy, I'll talk again about this. Dynamic self-adjustment. Interesting. What we can do with the technology itself is it's what we consider a phase lock loop. It's automatically at all times checking itself. What I mean by that, it looks at the brightness that it's set to, and it looks at the color rendition at all times, and verifies that it's staying at the brightness that you set it, and it's staying at the color rendition you set it. Now that's if we don't use maximum brightness. Of course, if we use maximum brightness, it's just going to decay. But if we put it at some other value, 80% value for instance, it will constantly check itself to make sure that the brightness stays there. So when we're looking at certain applications where we don't have to worry about, or want to have to worry about brightness changing or color rendition changing, it's a big factor compared to what lamp-based technology can offer. Here is just a little bit of a slide, and this is from what I've seen a couple of different manufacturers. This box right here is very similar for everybody. This is what we call a laser bank. In certain projectors, we'll have 8 laser banks of 8. We'll have 12 laser banks of 8, depending on the scenario. This lets you know that depending on what happens internally to that laser bank, if one goes out, one laser diode, the system continually runs and operates, and so you lose a certain amount of brightness, but you don't lose everything. If the whole bank goes out, like say for instance, one laser bank of 8 goes out, system still operates. You still have, you still get about 70% of the brightness on the screen, but you still have an operating system. You don't have what we consider a black screen. That as opposed to, of course, if a lamp fails. A lamp fails, we're done. We have no image on the screen. We can't do anything. So the very big merit is the fact that there's redundancy built into the system. Light source benefits, power adjustments. Show me a lamp-based system on the market today that can adjust the brightness from 20% to 100. And in some cases, we can go down to 10%. Lower black levels. Why is that? Because less light coming out of the system, there's less light scatter. So black levels change, so you get better black levels and it increases your contrast ratio. If we keep a constant brightness mode on this bottom here, you can see it runs for a long time. Eventually it will start dropping off because I can only increase my power so much. But that depends on where that value is. So here we're showing 70%. If we bring it down to 50%, that value is going to be out here in space, right? So we may be able to keep the brightness until they decide to change the technology and never have to do anything with the projector itself. Could never do that in the past. So it's a huge advantage for us, especially when we're looking at things that are like rear projection, simulation, command and control, knock centers, anything to that effect. That's one big avenue that we have an advantage of that we never had previously. Color critical. So for those color critical applications, the system itself, as I said before, constantly is looking at itself to make sure that the colors stay where they were or where you set it. So here, we're just showing you, here's the original color space. And after a few thousand hours on the lamp-based system, the colors are going to be obviously duller because of the fact that you don't have any brightness on the screen. This eventually will happen. Of course, it will eventually happen with a solid state. But that's at 20,000 or 40,000 or 50,000 hours, depending on where you have the brightness set. So this is something that you don't have to deal with on a constant basis. Key markets, when we look at a solid state, key markets, of course, corporate and education. That's a standard. Rental and staging, museum, house of worship, But the big ones that come into play that we never had before, digital signage, theme park simulation, control room. That disappeared, right? That used to be CRT projectors. Then it went to some LCD projectors or LCD lamp-based projectors. Then it went to flat panel. So now we can create seamless images with projectors in this environment that we haven't had the ability to do lately. So rental and staging, I think the most important part of projection technology in rental and staging, as well as digital signage in those scenarios, is the fact that it's not a fixed shape. So when we look at a flat panel, it's a fixed shape no matter what we do. It's a 16 by 9 of some sort for the most part. With projectors, we can create the content in any shape we want it to be. And only the content will show in that space. Everything else will be blacked out. So if it's a car, we can actually project an image on a car, and that's all you would see. So TCO comparison. Now this isn't just an NEC scenario, but I wanted to throw in a competitor's product as well. But it's looking at LCD-based projector here, the PA571. It's looking at a solid state. It's looking at a lamp-based system. And then it's looking at a Sony laser phosphor system. So just to give you an idea, look at what happens with the lamp-based system as far as price point. Same with the green line. They're both lamp-based systems. Eventually, over time, depending on the system, the TCO for the customer is well in their favor if they go with solid state over lamp-based systems, depending on that price point. This one is about the same price. Here it's a little bit lower, but 6-7 years down the road, they have a return. Now, that's if we're assuming maximum brightness. So with a laser system, talk to the customer, find out what that brightness point is. So if it is a 5,000 lumen product, what if you sell them a 6,000 lumen and put it in eco mode? Now you drop it down to 5,000 lumens. It's running in that space a lot longer, and they're not seeing that decay in brightness. Because what we're not really talking to customers about is the fact that if you sell them a 5,000 lumen lamp-based projector, in that few hundred hours, it's not 5,000 lumens anymore. So it may not fit that environment realistically. So now with solid state, we can upsell them intelligently by saying, hey, here's a scenario. What's going to happen is if you do this, you're going to have a better return. Yes, it's going to be a little costlier, more costly of a projector, but the advantages are much stronger. If it's a full brightness from day one until it's a linear line from if it's 6,000 lumens, from 6,000 to 3,000, it's 20,000 hours. It'll take 20,000 hours to finally get down to that. Linear. Completely linear, right.
So yeah, I did see the other one in the comparison was it's a lot flatter if you say 80%.
Yeah, if we run at 80%, 70%, then it's going to keep that brightness consistent.
Is that your recommended threshold, 80%?
I think it really depends on the environment. It's not really anybody's threshold. It depends on what the room lighting is. If it's rear projection, front projection. I mean, if it's rear projection, you can put it down to 40% and it'll be plenty bright enough, depending on the unit you're using, how big the screen is.
Would 80% be your recommended maximum?
Honestly, yeah, because I would design the space to use the higher lumen system and back it down to 80% so that we're keeping a consistent brightness over time.
Okay. Second question, something that was completely new to me was this concept of laser projectors being able to do the mapping / masking part of it that Gary Kay was talking about this morning. And I think there's an example of something like that in the exhibit hall space with a shoe or sneaker that you're projecting onto. Does that apply to all laser projectors due to the technology? Or he was talking about it being built in, like you don't have to purchase anything separately. And it's a feature I haven't noticed.
Yeah, and the reason it realistically can be any projector, rightfully, whether it's lamp-based or solid state. Solid state is promoted more because of the usage model. When I say the usage model, it's not going to be that 6, 7, 8 hours a day. It's going to be 12, 24, So when you are utilizing it that kind of hours in a day, solid state's really the only way to go because you would be replacing lamps every couple months. So So that's why we never really promoted it for that scenario. So solid state or lamp can do that, but it really is better from a solid state standpoint because you can run it longer hours. Thank you for your time. I appreciate everybody.